Welcome to Culture, Worldview, and Origins. We're Tim and Holly Nyquist. We're in Chapter 13, Kuhn's Critical Thinking, session number 7. The name of this chapter is Crisis and the Emergence of Scientific Theories. The previous chapter was the emergence of discoveries and facts. And what we have seen is that facts depend upon theories. And so now what we're looking at is crisis and the emergence of scientific theories. Now, a paradigm is based on a scientific theory. So when we have an emerging of a scientific theory, that is a destabilization or a crisis in a paradigm. A paradigm is not sufficient or is in process of being changed. He says, all the discoveries considered in section 6, the previous one, were causes of our contributors to paradigm change. So in other words, all the causes before were contributors to, but they were physical causes. They were things that did not fit physically, making new discoveries. Furthermore, the changes in which these discoveries were implicated were all destructive as well as constructive. When a new discovery comes in, and to be able to discover it, there had to be changes within the box. So that means there was destruction of old theories, destruction of old facts, destruction of old ideas, the old viewing, how to view things. But at the same time of destruction of the old, there was a construction of the new. And that's where I think that Thomas Kuhn is saying that the process of science evolving or changing to higher levels or to a finer practice is not linear, and it is not just successive brick upon brick and going up, but it is actually a change of paradigm that did no longer fit what they were studying. Because of the instruments, they could see further, they could see smaller, they could see things they couldn't see before, but they were anomalies. And so those anomalies are set aside, or the paradigm is adjusted to be able to take into the fact of these differences. So that is constructive as well as destructive. But that gain was achieved only by discarding some previously standard beliefs or procedures, and simultaneously by replacing those components of the previous paradigm with others. In the science world, there cannot be an operating science procedures without a paradigm. So if there is a paradigm change or a paradigm losing its grip, there has to be another one that is pushing it out of the way, because you can't practice science without a paradigm. So that gain was achieved only by discarding. The new paradigm coming in with new theories is not going like this and building, it's pushing. And so it's pushing the old paradigm out of the way. Discoveries are not, however, the only sources of these deconstructive, constructive paradigm changes. In this section, we shall begin to consider the similar but usually far larger shifts that result from the invention of new theories. A new theory is much more constructive and destructive than just a new discovery. A new discovery has to do with facts or with a worldview type thing, but when you're talking about theories, you're talking about fundamentals. You're talking about the base that supports the whole practice. How can theories like these arise from normal science? An activity even less directed to their pursuit than that of discoveries. So how does a new theory, discovering a new theory, come into play arise from normal science, because it is called normal science because it has a stable theory that it is operating on. It demands large-scale paradigm destruction. So in other words, when there's a new theory coming into town, it is not something of just a discovery of a sub-discipline, but it demands large-scale paradigm destruction and major shifts in the problems and techniques of normal science. The emergence of new theories is generally preceded by a period of pronounced professional insecurity. So in other words, the scientific community has been primed for change because there's an insecurity. There's too many anomalies. There's too many things going on that the current paradigm cannot address. So again, crisis and the emergence of scientific theories. As one might expect, that insecurity is generated by the persistent failure of the puzzles of normal science to come out as they should. So in other words, instead of producing something within the box, the puzzle's in the box, this is from outside the box, and so we need to change the rules within the box. We have to change the box. We have to broaden the box. We have to blow out the ends of the box. Given a particular discrepancy, okay, now we're going into some examples of different fields of science and how they ran into an issue that required a new theory. Given a particular discrepancy, astronomers were invariably able to eliminate it by making some particular adjustments in Ptolemy's system of compounded circles. So they adjusted things. They were able to adjust things within the paradigm. But as time went on, man, looking at the net result of the normal research effort of many astronomers, could observe that astronomy's complexity was increasing far more rapidly than its accuracy, and that a discrepancy corrected in one place was likely to show up in another. Trying to adjust things, adjust the theory to make it work, but it's creating more problems on the other end. And so it's created more problems than solutions. In the 16th century, Copernicus's co-worker, Domenico da Novara, held that no system so cumbersome and inaccurate as the Ptolemaic had become could possibly be true of nature. It can't be true. This paradigm that we're looking through is so inaccurate in its predictions that it can't be true to nature. There must be something else. So this is one issue of a change of paradigm. Going on to another one of gases. The net result of their experiments was a variety of gas samples and gas properties so elaborate that the phlogiston theory proved increasingly little able to cope with laboratory experience. Though none of those chemists suggested that phlogiston theory should be replaced, they were unable to apply it consistently. Phlogiston theory had to do with particles that made fire. And so it was a theory that something had enough particles of phlogiston, and that's why it burned. But when it burned, then it lost particles. That was not a correct theory. It was for its time, but they said there's problems with it. Now we're on to light. If light is wave motion propagated in a mechanical ether governed by Newton's law, then both celestial observation and terrestrial experimentation become potentially capable of detecting drift through the ether. That equipment, however, detected no observable drift, and the problem was therefore transferred from the experimentalists and observers to the theoreticians. New theory. They're saying it didn't perform like it was predicted to perform. There's something wrong with the theory. So instead of elaborating more experiments which have failed, we're sending it back to the theorists. In each case, a novel theory emerged only after a pronounced failure in the normal problem-solving activity. Crisis and the emergence of scientific theories, paradigm change. So that in each case, a novel theory emerged only after a pronounced failure and continuous failure. Finally, these examples share another characteristic that may help to make the case for the role of crisis impressive. The solution to each one of them had been at least partially anticipated during a period when there was no crisis in the corresponding science. And in the absence of crisis, those anticipations had been ignored. So in other words, there is notices that go up that say, hey, you need to make a correction to your theory. But instead of correcting the theory in totally, they might make some adjustments, and had made adjustments that then made problems further out. So what it came to is, even though they knew that there was things out there that were not being answered or addressed by their current theory, they kept adjusting the theory to try to answer those anomalies. But it couldn't, and so it led to a crisis. So instead of preparing earlier and adjusting and saying, okay, we need to reconsider the whole paradigm, they kept adjusting things smallly until they got to a crisis. And when they got to a crisis, then that was it. Things had to change. The absence of crisis, those anticipation, had been ignored. So long as the tools a paradigm supplies continue to prove capable of solving the problems it defines, science moves fastest and penetrates most deeply through confident employment of those tools. Okay, when everything is working well, when there are no anomalies, when there are no new discoveries, the tools provided by the paradigm get to fast-moving developing of that science. Crisis and the emergence of scientific theories. He goes on. Philosophers of science have repeatedly demonstrated that more than one theory can always be placed upon a given collection of data. Okay, yeah. Because it takes a theory to interpret the data, and then the data becomes facts. But what he's saying, philosophers of science have repeatedly demonstrated that more than one theoretical construction can be always placed upon a given collection of data. The theories can change, the data is the same, but it needs theories which are philosophically based, worldview based, to interpret the data into facts. So yes, multiple different theoretical constructions can be imposed upon one set of data. Data requires a theoretical set to interpret it into facts. And that is what we have with Stephen Jay Gould again. Theory, habit, prejudice, and culture all influence the way we see things, or the way that we perceive things and how we interpret things. And that's the question mark we have, the world, the lenses we see it through, and the conclusions that we come to. So crisis and the emergence of scientific theories. How do we come to a new theory? Different is through a crisis, and that the current paradigm can no longer answer these questions. And the questions generally they come because we have more specialized tools. We can get deeper into space, or we can see closer up into the molecular structures. And so then it creates more anomalies, which then, because of the apparatuses of seeing them, either we have to develop a new theory, amplified a theory, or change the whole theory because of what anomalies and discoveries have been presented, of what we've seen. And so what does crisis do? And the emergence of scientific theories. This is session number 7. We're wrapping up. This is chapter 13 on Kuhn and critical thinking. We're in culture, worldview, and origins. The topic is critical thinking skills applied to science. Thanks again for accompanying me. This is the end of session number 7. Thank you again.